Hello LEGO fans, welcome back to LEGO 48. A few weeks ago, I posted a video describing what I called a cardan gear mechanism. One of the first comments that I got in response to that was to tell me that this was not a cardan mechanism and I shouldn't call it that. That led to many hours of internet searching trying to figure out what this mechanism is called. The only reference to it that I could find is from this website, 507 Mechanical Movements, where it's described only as mechanism number 222. It's not titled, but it includes this description.
If for the eccentric wheel described in the last figure an ordinary spur gear moving on an eccentric center of motion be substituted, a simple link connecting the center of the wheel with that of the pinion with which it gears will maintain proper pitching of teeth in a more simple manner than the groove.
I asked AI for the name of this mechanism, and it gave me this.
If you are looking at historical mechanical engineering principles, the number 222 likely refers to a specific diagram in the classic text 507 Mechanical Movements, which illustrates a spur gear and link movement.
So, based on that, I've decided that the proper name for this is an eccentric motion spur gear and link mechanism, which I've shortened to the acronym EMSGAL. One of the next comments came from my friend Pinwheel, who noted that GBC modules with intermittent motion always capture my attention. And that got me thinking, how cool would it be to design a GBC module based on this specific mechanism? Not just featuring this mechanism, but specifically designed to highlight the properties of it. My thought was to have a belt made of track links with 3/4 pins stuck in the tracks and lift arms attached to those pins. I actually want 2 tracks in parallel for a wide lifting surface. To feed the belt, I want to use a variation of this butterfly gate that I designed when I first got into GBC. Instead of a single butterfly in a narrow channel, I want to stack up a whole row of them to make a cylinder with 2 ball channels in it. As I mentioned in my previous video, the rotation between pauses depends on the ratio between the input and output gears. If I make both of those gears the same size, I should be able to get a full 360-degree rotation of the drive axle, advancing the belt by 6 links at a time before it pauses. Then, I'll connect that axle to the butterfly cylinder using a 20-tooth gear to a 40-tooth gear. That way, when the main axle does one full turn, the cylinder will do half a turn, picking up a set of balls and dumping them onto the belt while it's paused. I want it to run for 2 to 3 seconds between pauses, or around 24 RPM. If I drive this with an XL motor, that means I need to gear it down 10 to 1 before driving the input of the EMSGAL mechanism. Before I started designing, I built a few prototypes to make sure the individual components worked. I began with the EMSGAL mechanism using 3 24-tooth gears. That works, and it's very nicely doing a full turn between pauses, as expected. I grabbed some 6-spoke sprocket wheels and a bunch of track links to try and prototype the belt. This iteration of the prototype worked really well. Finally, the in-basket and the butterfly cylinder. The first version mostly worked, but it would only load balls into the cylinder if there were other balls behind them, so the last row would never feed. So I went back to the drawing board and then I came up with this. The tiles in the in-basket sit a little lower than the first version, and the last part of it is actually curved slopes, adding just a little drop for the last few balls. This looks like it works perfectly as well. Putting all of this together, I came up with something that looked like this. The belt assembly will tilt up at an angle of about 45 degrees. It will be driven by the output axle of the EMSGAL mechanism, which in turn is driven by this 10 to 1 gear reduction here. The in-basket will be attached at the front, and then I'll add a chain to transmit power from the output of the EMSGAL to the drive gear for the butterfly cylinder. After putting this together, I set it up for some initial testing. Of course, if there's a GBC module on a tripod, Toffee is going to come and help. For the most part, this module worked as expected, and I think it's fascinating to watch. I started with the ball pump feeding 1 ball per second, which it handled fine. Later, I sped up the ball pump to see how this handled a higher number of balls per cycle. It still handled it well, but towards the end of my testing I noticed that the belt and the feed cylinder were no longer synchronized. I traced that to the fact that the chain had slack in it and was able to slip. I fixed that by adding another gear to take the slack up, and that seems to have solved the problem. I had to make some other tweaks to the design because the module was leaking balls when too many were fed in at once. This brings me to my second test, where I'm simply pouring balls into the in-basket to keep it full. And now the module seems to handle that just fine. For now, this module is mostly done. There are several places where I've had to use parts in the wrong color because I simply don't have the parts in the color that I want. I've ordered those parts, and hopefully I'll have them in time for Brickworld Chicago in a few weeks. In the meantime, here's my EMSGAL GBC module. Enjoy!